Here we have a SAT math problem. Okay, let's cover the question. In the XY plane above, the cross-section way of a tunnel under a bridge with an opening in the shape of a parabolic arc is shown. A large rectangular house trailer can be moved along a highway that passes through the tunnel. If the trailer is 8 meters wide and 6 meters tall, what is the height h in meters of the tunnel in the center? Okay, here in the given figure, we have to find the length of this vertical line segment over here. That is given by h. Okay, now to find the height of the tunnel h, what we have to do is we have to find the y-coordinate of the vertex of this parabola. Okay, here we have the two x-intercepts of the parabola. So the parabola intersects x-axis at the origin and the point 16, 0. So the two x-intercepts are x equals to 0 and x equals to 16. Since we know the two x-intercepts, we can write the equation of the parabola in factor form. That is y equals to a times x negative p times x negative q. Okay, here we have two linear factors, x negative p, x negative q. Now to get the two linear factors, we have to consider the two x-intercepts. In both the x-intercepts, we have to make the right side 0. Okay, the first x-intercept already we have 0 on the right side. So we can consider this x as one of the linear factors. Then we get y equals to a times, we can write this x over here. Now to get the second linear factor, we have to make the right side 0 in the second x-intercept. For that, we have to subtract 16 from both sides. Then I'm getting x negative 16 equals to 0. Okay, here we have 0 on the right side. Now we can consider this x negative 16 as the second linear factor. We can write it over here. Okay, now I got the equation of the parabola in factor form. Still, there is an unknown constant a over here. To get the unknown constant a, what we have to do is we have to plug in one of the points on the parabola into the equation over here. Okay, now we can consider the point b of 12, 16. Over here, we have this point on the parabola over here. So now we can plug in this point into this equation. That is, we have to plug in this x coordinate 12 for x over here, and the y coordinate 6 for y over here. Okay, let me do it. Then I'm getting 6 equals to a times 12 times 12 negative 16. Then I'm getting 6 equals to a times 12, and 12 negative 16 is negative 4. Then I'm getting 6 equals to 12 times negative 4 is negative 48. Negative 48 times a, we can write as negative 48a. Let's divide both sides of this equation by negative 48. When I do so, this negative 48 will cancel out. 6 goes into 6 one time, 6 goes into 48 8 times. I'm getting negative 1 over 8 equals to a. Here I got the value of a, that is negative 1 over 8. Now we can plug in this negative 1 over 8 for a over here in the equation of the parabola. Then the equation becomes y equals to negative 1 over 8 times x negative 16. Okay, now the equation of the parabola is complete. And also from the two x-intercepts x equals 0 and x equals 16, we can get the x-coordinate of the vertex. For that, we have to find the average of the two x-intercepts 0 and 16. For that, we have to add this 0 and 16 and divide by 2. Okay, 0 positive 16 is 16. When I divide 16 by 2, I'm getting 8. So 8 is the x-coordinate of the vertex. We can assume k as the y-coordinate of the vertex. Okay, here we have this vertex, that is the point 8, k on the parabola. Since we have this point on the parabola, we can plug in this point into the equation of the parabola. So that is, we have to plug in this x-coordinate 8 for x over here, and the y-coordinate k for y over here. Okay, let me do it. Then I'm getting k equals to negative 1 over 8 times 8 times 8 negative 16. Okay, here this 8 will cancel out. K equals to negative 1 times 8 negative 16 is negative 8. Okay, k equals to negative times 8 will become positive. 1 times 8 is 8. Okay, here I got the value of k. We can replace the k by 8. Okay, here the y-coordinate of the vertex is 8. So this 8 represents the length of the vertical line segment over here. So that is the height of the tunnel. Therefore, the height of the tunnel is 8 meters.